Alright, class, so this is going to be a really short video, alright? I know you're going to love it. The goal for you tonight is for you to be able to find the mean absolute deviation, alright, and discuss variability in a set of data. Alright, so here's what those two words mean. First, alright, the term mean absolute deviation. That's the average distance of all data values from the mean of the data set. Alright? And what I want you to do is put a star next to this, alright, and write down that deviation basically means difference. Alright, put a star next to this and write this down. Deviation basically means distance. Alright? So you're finding the distance of all the values from the mean or the average. Variability is described by the mean absolute deviation. Alright? So whatever we get for the mean absolute deviation, alright, variability is how we describe it. Alright, now that is represented with the acronym MAD. Alright, so over here when I have MAD, that means mean absolute deviation. Now, an arrow pointing up, that means high. Arrow pointing down means low. Okay, pretty obvious. A high mean absolute deviation means there is a high variability, which means there is a greater distance between the values. Alright, which means the values in the data set are spread far apart. Alright, if there is a low mean absolute deviation or a low MAD, that means we have a low variability. Alright, which means the distance between the values, alright, is, I don't know, pretty low. So for example, if I gave you the numbers, and put a star next to this and write down example next to this line. Alright, example. If I gave you like the numbers 3, 59, 72, and 112, those numbers would be spread far apart. Alright, that means their variability would be very high. Alright, because the average is going to be somewhere in between those, but all the numbers are pretty far away from the average. Low variability means the distance between the numbers, alright, is smaller. So, put a star next to this, write example next to this line. If your data set were, let's see, the numbers 4, 6, 9, 10, 13, and 14. All those numbers are pretty close together, right? So that means that the distance between them is pretty low, which means the MAD would be low. So it would have a low variability, okay? Next slide. Okay, this is how you calculate mean absolute deviation of a data set. So here I've got my data set, right? Alright, to find the MAD, the MAD, first thing you need to do is you need to find the mean, or the average. So we're going to add up all those numbers, and we get 45. Then, to find the average, you have to divide by how many numbers there are. So we'll divide 45 by 9, and we get 5. So that means that our average is 5. Now, what you have to do is find the differences, the second step. Find the differences between these values and the mean. So I'm going to do 5 minus 3, 5 minus 2, 5 minus 4, 5 minus 2. I'll do 9 minus 5, 8 minus 5, 5 minus 2, 11 minus 5, and 5 minus 4. Now, all the differences that we get between the average and those values, now we have to add these up and that's the third step, the last step, to find the absolute mean deviation. When we add up 2, 3, 1, 3, 4, 3, 3, 6, and 1, we get 26. Then to find that average, we divide by how many numbers there are, so we divide by 9, and we get 2.8 repeating. So that means on average, all the numbers in our data set are about 2.8 away from 5. On average, our numbers are about 2.8 away from 5. That's what that means. And you can see, class, these are pretty close together. So put a star next to this. Put a star next to this data set and write low variability, or lower. Write lower variability. All right, because the numbers are pretty close together. All right, next slide. Last one. I want you to try and find the mean absolute deviation of this data set on your own. Alright, so perform the same steps that we performed in the last problem. See if you can find out what the absolute mean deviation is. Okay, go ahead. Alright, first thing you should have done, find the average. So I'm going to add up all these numbers. I got 13, 1, 9, 18, 13, 3, 27, and 4. Now when I add all those up, alright, I'm going to end up getting 88. Then you got to divide by how many numbers there are. Well, there's 8 numbers, so I'm going to divide by 8. When you do that, 88 divided by 8 is 11. So that's the average. Alright, the average is 11. Now, I have to find the difference between all these numbers and the average. So, I'm going to take 13 minus 11. I'm going to do 11 minus 1. I'm going to do 11 minus 9. I'm going to do 18 minus 11. Okay, I'm going to do 13 minus 11. Alright, now I got 11 minus 3. 27 minus 11. And finally 11 minus 4. Okay. Now you know what? Let me my eraser's over here. Alright, you know what? We'll just skip it. I was going to make this a little bit lower so it's in line, but I know they're a little off. Now the differences. Alright, 13 minus 11, that would have given you 2. 11 minus 1 is 10. 11 minus 9 is 2. 18 minus 11 is going to be 7. 13 minus 11, that's going to be 2. 11 minus 3 is 8. 27 minus 11, that's going to be 16. And then 11 minus 4, that's going to be 7. Now, the mean deviation, the absolute mean deviation, you got to take all these differences, we got to add them all up and find the average of them. So, I'm going to do 2. Over here, we got 2 plus 10 plus 2 plus 7 plus 2 plus 8 plus 16 plus 7. Alright. I add all those up. Let's see. We get 12, 14, 21, 23, 31, 47, and 7, 54. Now I gotta take that 54 and divide by how many numbers there are. So there are 8 numbers. I'm gonna divide by 8. And for our answer, you're gonna get 6.75. That right there is your mean absolute deviation. So what that means is that on average, these numbers are about 6.75 away from our mean. Alright? That's what that means, 6.75. On average, the numbers in the data set are about this far away from 11. Okay? And that's it. Alright, so we're going to work on this a lot more in class. Alright, just make sure you're getting all these notes down, and I will see you all soon. Alright, take it easy.